Good morning, children. We'll start the class now. 14th question, 6.3. I think we left it. That we'll do first. Sides AB and AC, median AD of triangle ABC are respectively proportional to sides PQ and PR, and median PM of another triangle PQR. Show that triangle ABC is similar to triangle PQR. So here the question is given. Uh, me read once again. AB and AC and the median AD of the triangle ABC are respectively proportional. In the given part, if you check, you can see that we have written what is given in the question. This is given. AB by PQ equal to AC by PR equal to AD by PM. But here we have to prove that the triangle ABC is similar to triangle PQR only, right? So let us check if it is given AB and AC in triangle ABC only. If you consider AB is the and AC is given. So if it is given, then one more side we should get. So triangle ABC, which side is remaining? AC is BC is remaining, right? The bottom side that is remaining. But for that we don't have any information. So SSS criteria we cannot apply. So two sides are given AB and AC. Then we required the included angle A, right? Then only SAS criteria we can apply. So what we are having here, AB by PQ equal to AC by PR equal to AD by PM. So for proving this triangle ABC similar to triangle PQR, either we should get a triple S criteria or we should get a SAS criteria. So SAS criteria, if we are using there, means the included angle we should get. Already we got two sides, AB as well as PQ. The other side, if you consider, means which are the two sides correspondingly PQ and PR is given. So the included angle P should get. Here we need angle A, that side we need angle P. But regarding angle, we don't have any information. But at the same time, what is given that AD and PM are medians only. So as we know that D and M are the midpoints of the respective sides BC as well as QR. So you understood now. So we are having only two sides of proportion only for taking triangle ABC similar to triangle PQR. So we need one more included angle or otherwise one more side. Side is not possible here. So we need included angle. So here construction is required. So what is the construction? AD is extended to E such that AD and DE are equal, right? By construction. Similarly, PM and MN are equal this side. So here also we are extending PM to N such that a PM and a PMN are equal only. AD to AD to E such that AD and DE are equal only. Now what is the next? Join CE and as well as RN. So we have to join this, that in a color change we had done, that we have to join only. Now what we have to take means triangle ABD and a triangle CD. That means opposite angle. See this dot I will put here, this here. These two triangle we have to consider first. So what is the criteria? Already you can see that two equal sides are marked for triangle ADB as well as CDE. So the two triangle we are using here, two sides we are writing AD DE equal to by construction, BD and DC are equal to median property only. Now what is the one more? The included angle we required here. So the angle D equal to angle D, that is vertically opposite angle. So by SAS criteria, what we got here, AB and CE are equal. AB and CE means the opposite side. See here. AB and CE are equal. So that is the CPCT for this one. Similarly, if we do the same procedure here, what is the criteria? We'll get PM and MN are equal by construction, QM and MR are equal by median property. Then the included angle M are equal to angle M. Therefore, SAS criteria, that is also congruent only. And what is the result of this one? PQ equal to RN, right? So here what we got, AB equal to CE we got, and here PQ equal to RE. Now we are going back the first equation what we are written here. This is our first equation, right? AB by PQ equal to AC by PR equal to AD by PM. In the first step, we are replacing what I have made highlighted here. We are multiplying both the equations, that AD and PM, by 2 only. So 2AD we are getting. So the 2AD we are replacing. See that one, 2AD means what? See the diagram, AD equal to DE. So 2AD means the total length AE only. So that 2AD we are replacing with AE. Similarly, this triangle, if you consider, what is the replaced, pn only. Okay, so here pm, okay, one, pn I should write now. Okay, pm to n, so it should be written pn only. So here we can see that a pn only. So we got ae by pn. Now what is the next step? We should change ab and a pq. Just now congruency criteria we have applied. We got that ab equal to ce and pq equal to rn. So now we got, all the sides are in proportion. Now which triangle is similar? Triangle AC is similar to triangle PRN. Let us see the diagram once. Triangle ACE. AC is similar to triangle PRN. If it is similar, what is the result we can write here? Means angle CAE equal to angle RPN. Angle CAE. I'll mark here. Let us write 1 and 2, then it will be easy for you. By proving this, what we got, angle 1 equal to angle 2 only, right? So here we have written that the name of the angle only, angle CA equal to angle RPN. Now similarly, we should join the other two sides, which is the non-joint side, BE and the QN. We have to join. And if I write here this one, another congruency criteria we will get, and angle 3 equal to angle 4 by CPCT we will get. Understood? So here we got a angle 1 equal to angle 2 only. So I think here it is CAE. I have written here, this is first one, angle 1, and this is angle 2. Now I have written that BAE equal to QPN. BAE I have marked 3, QPN I have marked as a 4. So the same procedure, we are not writing that one. Similarly, we are writing. So what we are getting, angle 3 is equal to angle 4. Now if we add angle 1 and 3, the complete angle A will come here. Angle 2 plus 4, if we add, you will get a angle P. So that means included angles are equal by this property we got. So already we mentioned in the beginning that it is the sides are in proportion. Now we got included angles are equal. So the triangles are similar by which property? SAS criteria only. It is a lengthy procedure. As you know that it is MCQ pattern only, but this result is very good and it can be asked as a point of MCQ only. So the proof, you no need of studying, but the procedure you must know how we got all this thing. Well, once again I'll explain. Side AB and AC and median AD of the triangle ABC are respectively proportional to PQ, PR and median PM. So we have written AB, AC, then AD, and similarly PQ, PR and a PM. So we have written here corresponding sides are in proportion. Now what is the next step? We should prove that the triangles are similar. If we check what are the criteria are available to us, the two sides are in proportion only we got. So similarity criteria, as we know that triple S is there, SAS is there, then triple A is there. So by using this, we need one more included angle or one more side. Side, no chance, we are not getting any information regarding that one. So included angle only we can do. What is the construction that one? We are extended AD to E, similarly PM to N, in such a way that both are equal to each other. Then what we have taken, the opposite triangles we have taken and proved that the congruency. Then after the, what is the result? AB equal to CE we got. Similarly PQ equal to Rn from triangle PQR, right? So we got this one. That will be replaced by here CE by Rn. What is the next step? Here AD by PM we are multiplying with the 2. So we got AE by PN. If you consider all these three sides, that will be equal to which one? It is a triangle of ACE only, right? So that will be equal to triangle ACE similar to triangle PRN. So from this similarity criteria, if we go for the diagram, we marked easily that these two triangles are similar, then the angle also equal only. So angle 1 equal to angle 2. Similarly, what we are doing, angle 3 and angle 4 also equal. Now we are adding both the sides 1 and 3. If we add, see the diagram, what is the total angle here? It is angle A. Similarly, angle 2 and 4, if we add, what is the total angle there? Angle P. So with this, what we can write, the included angle, angle A and angle P are equal only. So what is the result? Triangle ABC similar to triangle PQR by SAS. Only this question is left from this exercise. The remaining all we have solved. Now I'll move on to the next exercise, that is exercise 6.4. Exercise 6.4 we required here. So okay. Triangle ABC in similar to triangle DF and their areas be respectively 64 centimeter square and 121 centimeter square. EF equal to 15.4 and find the BC only, right? All of you listen. This is based on which theorem it is. When the two similar triangles are given, the point is that when two similar triangles are given, their areas are equal to, do you remember this one, their a ratio of their areas equal to square of their corresponding sides. So the similarity already given ABC and DEF only, right? So similarity is given there, triangle ABC and triangle DEF. Then what is the case? The corresponding sides square ratio we can write AB by DE square, EC by BF square, AC by DF square only. So just to substitute the values, what is given in the question? It is given in the question that the areas are 64 and which one? Areas are 64 and 121, and the sides ratio equal to EF side is given. EF side is given means we should go for this one, right? So BC by EF square only we are taking from that one. So we are substituting and we are solving for BC. So what is answer? We are getting BC equal to 11.82 centimeter. So once again, what is the formula? When the similarity is given, then we can write area of the triangle ABC by area of the triangle DEF, right? Then corresponding sides only we should write. So AB by DE whole square, right? Similarly, the other side also we can write. So BC by EF whole square. So this is one of the important theorem only. So BC by EF whole square we have written. So BC by EF whole square we are using and we are writing that a BC by EF substituting, because EF value is given, so we can calculate BC only. There is no need of writing these two ratios also. We have written because of the formula only. So now what we can do, we can solve for BC. It is equal to 11.82 centimeter. Okay. The next question. Diagonals of a trapezium ABCD with AB parallel to DC. So I'll mark AB parallel to DC. Intersect each other point AB O only. Sorry. If AB equal to 2CD, find the ratio of the areas of the triangle AOB and COD. Here you must be very clear that the triangles are not similar. It is not given to us. Understood? So first you should check that whether they are similar or not. That is the first point we have to do such questions. So the ratio, the areas of the triangles we have to prove means we should do that. What? That triangles are similar we should prove. Okay, so diagonals of a trapezium ABCD with AB parallel to DC we have written. So naturally alternate interior angle property we can use, vertically opposite angle we can use. So the triangle which are we are considering, triangle AOB and triangle COD we are considering, and one is alternate interior angle, second also alternate interior angle, third one is vertically opposite angles. After that, what is the criteria? It is AAA rule only, they are similar. Once it is proved similar, similar, then only this theorem can be applied. The ratio of the areas. Area of the triangle AOB by area of the triangle COD equal to AB by CD whole square. This time AB by CD we have written. Why? The reason is AB equal to 2CD is given in the question, right? So we have written that much only, AB by CD whole square. Now we are replacing AB as 2CD. See this one? It is equal to 2CD by CD whole square. So CD will get cancelled, right? So what is remaining there? 4 by 1. So what is the ratio? The ratio is 4 is to 1. So the point where you are wrong means, you may do the mistake means, we should check that whether the triangles are similar. Then only this theorem can be applicable. Without similarity, if you are applying this one, then it is no use. Understood? So first check that whether the triangles are similar. If it is similar, then this result can be used. Next question. ABC, DBC are two triangles on the same base BC. If AD intersects BC at O, show that area ABC by area DBC equal to AO by DO. So this question we cannot do without construction. So again, we have to find the area only. So what is the point first? We have to prove that they are similar only. Let us check that one, how it is possible. Otherwise, one more method is the area formula also we can use. Let us see this question how it is. The construction is already done here. Draw AP and DM. That means perpendicular to common base BC only, right? So the perpendiculars are drawn here. Now let us take this small triangle, whatever after the construction, which is the triangle you are getting, triangle APO and a triangle DMO only. So angle P and angle M are 90° only by construction. Angle O is a vertically opposite angle. So this criteria we can suddenly we can use here. What is the criteria? Double A only. So what is the question we can write here? So here APO is similar to DMO by two angle criteria only, that is double A criteria. Now here what is the formula? Because we have proved that these two triangles are only similar, which is that APO and DMO, but we should prove that area ABC and DBC are similar, right? So there is no similarity we are proved here. So our normal formula we are using here. So half base into height only. So here one correction is there. It is DM. Let me correct. I'll explain. Okay, so listen all of you. What is the formula? Normal formula for any triangle, half base into height only. What is the half base into height? Because both are having common base, which is that one BC only, right? Now by construction we have seen AP is perpendicular here, DM is the perpendicular. So half into BC into AP divided by half into BC into DM. So after BC cancellation, see BC is cancelled, half is also cancelled. So what is remaining here? AP by DM. What is remaining here? AP by DM. Now we already proved that AP by DM is equal to AO by DO. So we can take down AO by DO. Hence proved. So once again the question, both triangles are on the same base BC, they intersect at O only. We should prove that area ABC by area DBC equal to AO by DO. So when we go for AO by DO, it is not possible for us. It's a part of the diagonals only. So what we have to do? We have to draw the perpendiculars, which is the perpendicular AP as well as DM. So we draw the perpendiculars like that. So we drawn that one and we proved that the new triangle that is here and this one, right? These two triangles are similar by AA criteria. After that, what is the criteria? We have to use we should write the corresponding sides. So all the three sides we have written by the result. Now again we are using the formula area triangle ABC by area of the triangle DBC. Our normal formula half base into height. The base will get cancelled, half is also will get cancelled. So what is remaining there? AP by DM. So AP by DM equal to AO by DO. So we got the result AO by DO, which is equal to area ABC by area DBC. The next question. If the area of the two similar triangles are equal, then prove that they are congruent. That means two similar triangle only. Let us take triangle ABC similar to triangle PQR only. So area, once a similarity written, but we can write a sides square of the ratio, the corresponding sides we can write. That is our theorem, right? So area ABC by area PQR equal to AB by PQ whole square, BC by QR whole square, AC by PR whole square. I think there is no doubt this is a theorem only. We have written that one. Now what is given here? The similar triangles areas are equal. That is the next step. Area ABC equal to area PQR. That means left side it is 1 only, right? So left side it is 1 means AB by PQ whole square is also equal to 1. BC by QR whole square equal to 1. AC by PR that is also equal to 1. Now each ratio we are making equal to 1 only. So what is that one? AB square, AB by PQ whole square equal to 1. Only one ratio I am talking. AB by PQ means what we can write? 1 equal to AB square by PQ square. After cross multiplication, this PQ square will come here. So that is the next step. AB square equal to PQ square. Now, similarly, this side you can complete BC square equal to QR square. AC square equal to PR square. After taking the square root, AB equal to PQ, BC equal to QR, AC equal to PR. Now we got all the three sides are equal. So SSS criteria, it is not similar now. What is the criteria now? It is a congruency rule. When the sides are equal, what we can write? They are congruent. And one of the important question only, but now the proof is not there for you, but they can ask for which is the criteria we have used. So since they are congruent, by which criteria, like that they can ask in the paper. So the two similar triangles are equal, prove that they are congruent also. That means left side it becomes 1, right? Because they are equal. Now these ratios are equal to 1 only. Now AB by PQ whole square equal to 1. That means AB square equal to PQ square, or we can say AB equal to PQ by taking the square root. All the three sides are equal. Here you can see that one. What is the result of this one? Triangle ABC similar to triangle PQR. Not similar, it is congruent. Triangle ABC congruent to triangle PQR by SSS criteria. Okay. Another question. D, E, F are respectively the midpoints of the sides AB, BC, and CA of triangle ABC. Find the ratio of the areas of triangle DEF and triangle ABC. Already this question we have done in the ninth class. That is triangle ABC is divided into four congruent triangles. If you remember that one, we know that the whole triangle is divided into four congruent triangles only, right? We since it's a deleted chapter for the last year, area of the parallelogram, when the congruent triangles are there means their areas are also equal only. Now we are going for midpoint theorem that you have already studied. What is given here? D, E, F all are midpoints of the respective sides only. So if you consider that is FD, that means here the upper line, this FD if you are considering, both are midpoint only. So if you studied the midpoint theorem, the line segment joining the midpoint of any two sides of the triangle is parallel to the third side and half of that one. If you remember that one, we can go for this, right? So what is the condition? D and F are midpoint. If D and F are midpoint means both are parallel to BC. The line segment DF is parallel to BC, and moreover DF equal to half of BC. Similarly, ED, if you are taking, ED is this line only, right? From here to here. It is parallel to AC only possible, right? So AC this one. So ED parallel to AC, and also ED equal to half AC. Similarly, EF, this is the third side. EF equal to half AB, and EF parallel to AB. Opposite side you can see that one, right? So this is by midpoint theorem. So I'm bringing to the order I changed. EF by AB I have written first. This I have chosen as a first one, right? Okay. So what I have written, EF by AB I have written. The ratio became 1 by 2 only. Similarly, FD by BC. This is the second I made. uh, FD by BC, that is also equal to 1 by 2. We are bringing to this side. So what will happen? ED by AC equal to 1 by 2. So all the three sides ratio, if you take, it will be equal to 1 by 2 only. So SSS criteria, these two triangles are similar. So what is the criteria? Both the triangles are similar. Then we can go for corresponding sides. So EFD by area triangle ABC means EF square. Any side you take, corresponding side, EF square by AB square, it will be 1 by 2 whole square only, because the ratio we have got here 1 by 2, right? So 1 by 2 whole square we are substituting, and it is equal to 1 by 4 only. So this is also good question only. D and F are the midpoint. Where is that? So what we should use? The midpoint theorem only. Then we are applying the concept. So all the three sides are in the corresponding sides ratio we got. Then the triangle two are similar. Then we can write that if it is similar, the ratio of their the ratio of their corresponding sides square is in the same ratio. So square we can take, that is equal to 1 by 2 square equal to 1 by 4 only. Okay. One more question. Prove that the ratio of the areas of the two similar triangle is equal to square of the ratio their corresponding medians. We already proved the theorem for ratio of their corresponding sides. Square of ratio of their corresponding sides. Now this word is here changed it into medians. So we already know that when these two triangles are similar, what we can write? All the three sides are in the corresponding ratio. Now instead of BC, we should bring it to BD. So what we are doing? We are dividing both the equation by half. So BC, half of BC means it is BD only. So AB by PQ equal to BD by QS. So we got here AB by PQ equal to BD by QS. Now what is the next step? One included angle is required, and that is angle B equal to angle Q. So SA's criteria, these two triangles are similar only. One similarity we have proved, the corresponding sides squares we can take down. So AB by PQ whole square, BD by QS whole square, then AD by PS whole square. So which is required? Median only required. So the third ratio we are taken. So once again, here we have proved that when the two triangles are similar, we already know that the ratio, square of the ratio of their corresponding sides, we know that by theorem. Now the sides we should change into median only. So what we are written, first side ratio we are take down, then the median side we are take down, that is a we have considered BC only. BC we are dividing with it 1 by 2, or QR also multiply with 1 by 2. So that half BC we can replace with BD as well as QS. Now we got sides ratio here. Now the included angle is required. So included angle, let us check AB is here. Now we got a BD only. I should not mark equal sign. So the included angle is which one? Angle B, right? Angle B is the included angle. So the included angle we have taken, that is angle B and angle Q only. How we are taken that one? Because it's already given that the triangle is similar. So we are using that. Then angles, all angles are also equal only. So we have used once similarity proved, what we can write? When we are considering area, we can write square of ratio of corresponding sides. From this, we required this as well as this side. So we have proved that it is also equal to square of corresponding medians also. Prove that the area of an equilateral triangle described on one side of the square is equal to half the area of the equilateral triangle described on one of its diagonal. Here both are equilateral triangle only. Both are described on square. How the difference? One triangle, that is the equilateral triangle AEB, that is on side of the square. But when we are considering BFD, it is on diagonal of the square. Understood? So we are having two triangles. The triangle AB is on side AB and the triangle BDF is on diagonal. So the diagonal length of the square we must know. If the side is x, the diagonal we already know that it is root 2x only by Pythagoras theorem. So we have taken square side equal to x and the diagonal equal to root x, or root 2 into x only. Now we already know that equilateral triangle means all the angles are equal only, all the sides are in the same ratio only. So we can go for either AA criteria or SSS criteria. These two triangles are similar. So no proof is required. It's a direct result only. So we have written AB by BD. Area we are taken in the ratio form. Now any two sides we can write, that is one is AB, another one is a diagonal. So AB by BD whole square it is. So x by root 2x whole square, that is substitute, it is equal to 1 by 2. Now how to prove that one? Area of an equilateral triangle described on one side of the square, which is that one triangle ABE, equal to half area of the equilateral triangle described on one of the diagonals, which is that one triangle BDF. We required the result in this form only. So now we got that 1 by 2 here. So we are keeping AB this side and half into we are taking to this side. So half into area of the triangle BDF. Both the triangle are equiangular triangle only. All the angles are equal. So you can go for SSS because the sides are in same proportion, or equiangular means A criteria. Any criteria you can use it. Just simply you take down because all the angles, all the sides are having the same ratio. So once the similarity we have proved, what is the next step? Ratio of the areas we can write AB by BD whole square. Now we are substituting the values because AB we have taken as x, the diagonal BD we have calculated, it is root 2x only. So we are substituted and it is equal to 1 by 2. Just we are taking to the other side, cross multiply, we are getting the required result. Triangle ABC and a triangle BD are two equilateral triangles. D is the midpoint of BC, ratio the area of the triangle ABC and BD. Once again, it is equilateral triangle. We know that they are similar only, right? So both are similar. If it is similar, what we can write? A square of the ratio of their corresponding sides. So we have taken as BC and a BD relation. BC is 2 times BD because D is the midpoint. So BC by BD whole square. So it is equal to 2x by x whole square. It is equal to 4 is to 1 only. So which is the option? That is C is the correct option, right? So this is again the application of the result only, nothing else. So here we can go for the direct one because it's optional question only. So both the ratios area we have considered and the corresponding sides square we have written. Then we substitute the values and we'll get only the point where D is the midpoint. So that means BC means 2 times of BD. I think one more question is there. Sides of two similar triangles are in the ratio 4 is to 9. What is the area of these triangles ratio? So one side is the ratio means 4 by 9. When area means it is the square only. So 4 by 9 whole square, it is equal to 16 by 81. So the means answer is D only. So direct application of the theorem only. Sides ratio is given. We should go for area. Area means square of the ratio of the corresponding sides. So 4 by 9 whole square, it is equal to 16 by 81. I think the exercise is completed. So with this, today's class I am winding up.